Hey guys, sorry I can't be here today. Um, what I need you to do is follow along in the notes, pause the video when you need to. If you have any questions, I will answer them next time. And as always, I stay after on Wednesdays if you want to stay after or come down during your study hall. Okay, so I have very little notes for you. Today the concept is fairly simple. It's just one additional piece added onto our proofs. So if you've been doing okay with proofs, this really shouldn't be any harder. Okay, so this new idea is called CPCTC. You need to know what that stands for. And what it stands for is corresponding parts of congruent triangles are congruent. So make sure you write that down. You need to know what it stands for. Okay, corresponding parts of congruent triangles are congruent. Let me explain what this idea is. What it means is we have two triangles, and what we've been doing up until this point is we have been proving that triangles are congruent. This is one additional piece into that. So let's say I already have markings on my picture. Okay. So normally what we've been doing is we would look at these two pictures and we would say, okay, are these triangles congruent? We would say, yes, they are because of angle, side, angle. So that's what we've been doing. Triangle ABC is congruent to triangle XYZ by angle, side, angle. Now what we're doing is we're going to add one additional piece to that, and we're going to start proving things like, let's say, angle A is congruent to angle X. We are allowed to say that because of CPCTC. So what this means is that if you have unmarked parts and triangles that are already proven congruent, we can also say those unmarked parts are congruent. So another example, I could prove that segment AB is congruent to segment XY because they are corresponding. They're in the same place. Once these things are already proved congruent, we can say that the unmarked parts are also congruent. So it's corresponding parts. If you're trying to prove just parts of the triangle, whether it's segments or angles, this is what you want to use. So I'm just going to show you some examples of how this is used in proofs, and that will be it for our notes. So first thing you always want to do is mark what you know. S is the midpoint of QT, which means that QS and ST are congruent. You can kind of, if you want to mark everything out first, or if you want to go through the proof and mark it as you go, whatever works for you. It's just going to take some time and practice to figure out what the best way is to solve these. So, they also tell us that QR is congruent to, not congruent, but parallel. That's why the arrows are here. So these are parallel to each other. Well, remember, if you have parallel lines and a transversal, we have alternate interior angles are congruent. Okay, so I'm going to hold off on that because there's a lot of things I can mark because of that. I can mark Q congruent to T, I can mark R congruent to U, and then I can mark, vertical angles. There's a lot of things that I can mark. So I'm just going to hold off and start filling in my proof, seeing where they want me to go with it. Because if you already have parts of the proof filled in, then you have to go in the direction that it's going in. If we were doing one from scratch, we could do it, solve it however we wanted to. Okay, so first part should always be given. And then QS is congruent to ST. That's something we marked on our picture. Why did we mark that? Because we were told that S is a midpoint. And as I mentioned before, if this says something about a midpoint here, I'm probably going to mention that again. So definition of midpoint. Now angle Q is congruent to angle T. Alright, so we were talking about this. Why are those congruent? Because parallel lines with the transversal make alternate interior angles. So this is definition of alternate interior angles. And that's why I held off on marking the picture just for this one, because I didn't really know where the proof wanted me to go. I don't want to mark a bunch of stuff and then not end up needing it. Okay, so now angle RSQ is congruent to TSU. Well, those are vertical angles, so we just say definition of vertical angles. Okay, these triangles are congruent because of angle, side, angle. Now here's where the new thing comes in. This is all old up until this point. You guys should feel pretty good about steps A through E. Here's what's new. We're trying to prove that QR is congruent to TU. Those are parts of a triangle. QR and TU, those are segments. So that is by CPC/TC. And some of you might be thinking, well, why did we need to say that? We already knew that because of the markings. Remember that these arrows mean parallel, not congruent. Just because two things are parallel does not make them congruent. Alright, at this point, if you feel like really good about this and you want to go and try one on your own, go for it. If you want to watch me do it, that's fine as well. It's up to you. Okay, I'm going to go ahead and mark what I know. A lot of this is already marked for me within the given, so that's great. You can go ahead and mark what you know. You know the shared side is congruent. And then we just have to fill it in. If you want, you can go ahead and start thinking about how are these congruent. We can already tell by looking at these that these are congruent by side, side, side. So you're kind of solving it, then you kind of talk about it afterwards. And some people like to go step by step. It's up to you. Alright, so our first piece should be whatever was in the given. So I'm going to write down all this stuff that was up here. Copy that down. Okay, what did we mark that would be reflexive property? Well, that's where something is congruent to itself. Well, we marked TS as congruent to TS. We marked the shared side. So shared side, reflexive property, those go together. Now we see the triangles are congruent by side, side, side. And here's where the new thing comes in. We are talking about parts of the triangle. We are saying that R and U are now congruent because they're in, corresponding parts of congruent triangles. Really makes a lot of sense when you think about what this means. Okay, last one. Again, mark what you know. We have the shared side. And in the given, we have a little bit different information. GE bisects DEF. So this line right here is bisecting this angle, which means it's cutting it into two equal parts. Okay, so where do we get this from? The given. Definition of angle bisector. Well, what did we end up marking on this picture because we knew something was a bisector? We said these two angles are congruent, so angles DEG and angle FEG are congruent because of that. Why is GE congruent to GE? That's reflexive property of congruence. Why are the triangles congruent? We have two angles and a side. Is that side sandwiched in between? No, so this has to be AS. Okay, last part, what we're trying to prove. Angle DGE is congruent to angle FGE. Or not angles. Oh yeah, sorry, angle is correct. Okay, so let's find those angles. Angle DGE, that's this piece and this piece. Why are those congruent? They were unmarked, they're parts. Now that we know the triangles are congruent, we can say that parts of the triangles are congruent by CPC/TC. So that's it. That's the new thing. I just wanted to tell you what CPC/TC stands for, how to use it in a proof, and that's it. So what I'm going to have you do now is a worksheet. When you are finished with that worksheet, check your answers on Blackboard. You can also have them pulled up as you're working on it. It's up to you. When you are finished with all of that nice hard work, I need you to start reviewing for your quiz. And I made a nice little review for you, so please do it. Please check your answers on Blackboard. If you have questions, ask me. I will, as always, answer any questions you have before the quiz. The quiz will be next class, so please prepare. All right, good luck.